In this video, we're going to look at factoring quadratics or trinomials of the form ax squared plus bx plus c. Before we do that, we are going to review expanding a quadratic in factored form. So one method is to take 2x plus 5, multiply by the 3x, and multiply by the negative 1. And that'll give us 3x times 2x plus 5 minus 1 times 2x plus 5. Next is to distribute the 3x into the first bracket and then the negative 1 into that second bracket. And we end up with 6x squared plus 15x minus 2x minus 5. And finally, collecting like terms, we end up with 6x squared plus 13x minus 5. So today we're going to look at going from our standard form all the way back to factored form. So starting here and getting all the way back to here. So let's do this by working on an example. So the first example we want to look at is 6x squared minus x minus 1. And you notice the first step in what we just did here, so looking above again, to go from here to here, we need to break up the middle term into two parts. Notice the 13x is the same thing as 15x minus 2x. So how do we get those two numbers is where we need to start. And here's how we do so. We need to find two numbers that, first of all, add to the middle term. So in this case, add to the b value, which in the example here, we see that b equals negative 1. That's right here. And multiply to a times c. And if we look at a times c, so ac, that a is 6, c is negative 1, and 6 times negative 1 is equal to negative 6. So the best way to do that is to look at factors of negative 6. So what are the factors of negative 6? So two numbers that multiply to negative 6. We have negative 6 and 1, or we have 6 and negative 1. We have negative 3 and 2, or we have 3 and negative 2. So there are factors of negative 6. Negative 6 times 1, 6 times negative 1, negative 3 times 2, and 3 times negative 2. So we did the first part. They multiply to AC. The next thing we need to find is that they have to add to the b value. So let's add these numbers together. Negative 6 plus 1, that's negative 5. So that doesn't work. 6 plus negative 1, that's positive 5. That doesn't work. Negative 3 plus 2, that's negative 1. And if we look at the last one, that would have been positive 1. That doesn't work. So we see negative 3 times 2, that gives us our negative 6. And if we add those two numbers together, they give us negative 1. So I call these the magic numbers. So the magic numbers are negative 3 and positive 2. So what do we do with them? That's the next part. We take our equation, 6x squared minus x minus 1, and we use the magic numbers to split up that middle term, this negative x. So we end up with 6x squared. The first magic number was negative 3, so that's negative 3x, plus 2x minus 1. So notice, if we were to add negative 3x plus 2x, we would get back our negative x. So this is the step we talked about above. We're going from where the red arrow is, we're going from here to here. We found the magic numbers that break apart that x term. All right, what's next? So the next part is to factor by grouping. So I'm going to take each pair of terms and find their common factor. If I look at the first two terms, I see that there's a common factor of 3x. And what I'm left with is 2x minus 1. In the second two terms, the only common factor is 1. And again, I'm left with 2x minus 1. Notice that we now have 3x times 2x minus 1 plus 1 times 2x minus 1. So now we can common factor. Our common factor we now see is 2x minus 1. And what's left over is our 3x plus 1. And notice we now have our quadratic in factored form. So we're going to practice this a few more times, and I'm going to give you some tips to make some of the more complex factoring questions simpler. So let's go through those steps. So we have 2x squared plus x minus 6. So first off, we need the magic numbers. I need a number that adds to b, and b is 1. And I need a number that multiplies to a times c. And a times c, that's 2 times negative 6, is negative 12. So here's our b value. That's 1, because there's 1x. And here's a and here's c. So 2 times negative 6, and that's negative 12. So next we got to look at factors of negative 12. So factors of negative 12 are negative 12 and 1, 12 and negative 1, negative 6 and 2, 6 and negative 2, negative 4 and 3, and then 4 and negative 3. If we add these up, we have negative 11, 12 plus negative 1 is 11, negative 6 plus 2 is negative 4, positive 4, negative 1, 1. That's the one we're looking for. And eventually you won't have to go through them all. You'll be able to pick these numbers off quickly. So our magic numbers here are going to be 4 and negative 3. 4 times negative 3 equals negative 12, and 4 plus negative 3 equals positive 1. The two values that we're looking for. So now let's work on the problem. We have 2x squared. We need to split up this x, and we see that 4 and negative 3 were our magic numbers. So I get plus 4x minus 3x minus 6. Next step, factor by grouping. Take out the common factor from the first two. That leaves me with x plus 2. And the common factor from the next two. That leaves me with x plus 2. So notice I took a 2x out of the first two terms and a negative 3 out of these second two terms. Again, we see that we have 2x times x plus 2 and negative 3 times x plus 2. So our common factor is x plus 2, and we have left over 2x minus 3. There is our quadratic in factored form. All right, b. Let's keep going. So for b, I need two numbers that add to negative 6, the b value, and multiply to a times c, which is 9. So think of factors of 9. 9 and 1, 3 and 3, negative 3, negative 3, negative 9, negative 1. Which set will add up to negative 6? Well, if you chose negative 3 and negative 3 for your magic numbers, negative 3 plus negative 3 is negative 6, and negative 3 times negative 3 is positive 9. Those are the numbers we're going to split negative 6t into. So we end up with 9t squared minus 3t minus 3t plus 1. The common factor in the first two terms, because we're factoring by grouping, is a 3t. And we're left with 3t minus 1. For the next two terms, while 1 is the common factor, we can also take out a negative 1, because remember, if the leading coefficient is negative, we want to take that out. So negative 1, and that leaves me with 3t minus 1. And notice again, we now see we have a common factor of 3t minus 1. So if we take out the 3t minus 1, we see we're also left with the 3t minus 1. So if we want, we could rewrite this as 3t minus 1 squared. Let's keep going. Next example, and again, pause the video and try these yourself. This one has a trick because you're missing the x term. But let's add that in there. So that's 4x squared plus, we have a 0x, and then minus 9. So I need two numbers that add up to the b value, which is 0, and multiply to a times c, which is 4 times negative 9. That's negative 36. So think about that. Two numbers that multiply to negative 36 and add up to 0. Again, pause the video, see if you can figure those two numbers out. So the two numbers you should have ended up with are negative 6 and positive 6. Negative 6 times 6 is negative 36, and negative 6 plus 6 is 0. So for our next line, we have 4x squared. Remember, we've broken up the 0 into minus 6x and plus 6x. So that's what we did here. And we still have the minus 9. Again, we're going to factor by grouping. So the first pair have 2x as a common factor, which leave you with 2x minus 3. And the second group has 3 as a factor, which leaves you with 2x minus 3. Notice if we've done everything correctly, we now have a common factor for both terms. So what we have is 2x minus 3, and we're left with 2x plus 3. So that's the trick if you don't see the x term. All right, let's keep going. Next one. I need two numbers that add up to negative 20 and multiply to 4 times 25, which is equal to 100. Pause the video and see if you can figure out two numbers that multiply to 100 and add to negative 20. So what you should end up with is negative 10 and negative 10. So what we now have is 4y squared. So instead of an x, we have y's. So that's negative 10y minus 10y. We split up the 20y, or negative 20y, into negative 10 and negative 10, plus 25. Again, factor by grouping. In the first two terms, we have a 2y, which leaves me with 2y minus 5. And in the second two, the leading coefficient is negative, so I'm going to take out a negative 5, and that leaves me with 2y minus 5. Our common factor is 2y minus 5. So what we have left is 2y minus 5 times 2y minus 5. All right, let's keep going. These last two, there's a trick involved when you're going to factor expressions. The first thing you should always do is common factor first. If you common factor first, a lot of questions will become simple. So you notice for e, it doesn't look really like a quadratic. If we remove the common factor of 3x first, we're left with a y squared plus a 3y plus 2. And notice the y squared plus 3y plus 2 looks like a quadratic expression. So now we focus on just this part. The y squared plus 3y plus 2. The 3x just stays in front like a spectator. We need two numbers that now add up to this new b value of 3 and multiply to a times c, which in this case is 1 times 2, which is 2. So again, what are the two magic numbers for this quadratic expression? So you should have guessed that 2 times 1 is equal to 2, and 2 plus 1 equals 3. So 2 and 1 are our magic numbers. So the way we would solve this one is we'll leave our 3x out front, we now have y squared plus 2y plus y plus 2. We split up that 3y into 2 and y, because 2y plus y is equal to 3y. Just going through the same steps, we're going to factor by grouping. So we have 3x times, in the first pair we have a y, and then a y plus 2 as our next factor. We took out a common factor of y. And in the next two, it's positive and there is no common factor that we can see, so we're going to take out a 1, because everything has a common factor with 1. And we have y plus 2 again, which is great, because now we have a common factor of y plus 2, which gives me a 3x. We take out the y plus 2, and what we're left with is y plus 1. And you've actually factored a more complex equation. So there's the factored form of this expression from the top. All right, last one. One of the most important rules for quadratics or factoring is common factor first. If we take out the y that we see here, notice we're left with y squared plus 7y plus 12. We have y times some quadratic expression, y squared plus 7y plus 12. So now we need to split up that 7y. So I need two numbers that add to the b value of 7 and multiply to a times c, which in this expression is 1 and 12, so 12. So what two numbers multiply to 12 and add to 7? And these magic numbers are going to be 4 and 3. So if we continue, we have y, then we have y squared. So we split up the 7y, and it becomes 4y plus 3y, and then plus the 12. So again, our magic numbers take that 7y and say split it up into 4y and 3y. Then we're going to common factor, because we have 4 terms there. So we have y. The common factor for the first two terms is just y, and that leaves me with y plus 4. And the common factor in the next two is a 3, which leaves me with y plus 4, which is perfect because we now see we have y plus 4 as our common factor. So we have y. We take out the y plus 4, and what do you have left? Y plus 3. And once again, we've factored a more complex expression. So this in standard form becomes the expression in factored form.